So remember that there are 6 types of reactions, and so far we have looked at synthesis and decomposition. Today we will be looking at single displacement and double displacement reactions, and next week we'll go into acid-base neutralization. Single displacement reactions. These are chemical reactions that involve one element and one compound that are going to be found as our reactants. The single element is going to displace, which means it's going to switch spots with one of the elements in the compound to form a new substance. So there are 2 types of reactions that can occur. You can have a metal displacing a metal, or you can have a non-metal displacing a non-metal. So here's an example where your metal is displacing a metal. So remember, metals are written first in our compounds. So you have a single element, which is going to be a metal, and it's going to switch spots with the other metal. So Z is going to want to recombine with B in this case to give us ZB, and then we have A on its own. Your nonmetals are found in the second part of our formula. So in this example, when a nonmetal displaces a nonmetal, your A and your Y are going to recombine. Metals are written first, nonmetals are written second, and then B is going to be found on its own. So these are the only 2 types of reactions that are going to occur with single displacement. So here let's look at a specific example where a metal is displacing a metal. What you need to remember is that you need to re-crisscross charges for elements that are combining. So in this example here, I have magnesium and silver nitrate. So I could see that magnesium is a metal, so it is going to want to displace the silver in the silver nitrate compound. So they're going to switch spots. So what we should be left over with is you're going to get magnesium nitrate and you're going to get the silver on its own now. The next thing that you're going to need to do is you're going to need to convert this word equation into a chemical equation. So remember to use your periodic table to determine charges and to crisscross the charges in a compound. Magnesium is found on its own, so I'm going to see magnesium on its own. Remember that elements found on their own should not have a charge, so I shouldn't see a +2 over here, as well as remember Hofbrinkel. So magnesium is not a Hofbrinkel, so I should not see a 2 over here. Then I'm going to crisscross silver and nitrate. So silver is Ag and it has a +1 charge. So maybe you can write at the bottom. And your nitrate has a -1 charge. So when you crisscross these, that's going to give you the formula that you need to write in your chemical equation. So I'm going to get AgNO3. And I'm going to do the same to determine my magnesium nitrate now. So magnesium is Mg2+, and my nitrate is NO3 -1. So when I crisscross my charges, I'm going to be left with the 2 outside of the nitrate. So I'm going to use brackets, and that's going to be my magnesium nitrate. And then I'm also going to have now silver on its own. So silver is not a Hofbrinkel. I shouldn't see a 2, and it shouldn't have a charge. Now I need to make sure that my reaction is balanced. So I'm going to start off with my metals first. So magnesium, I have 1 here and 1 here. So magnesium is balanced. My silver, I have 1 here and I have 1 here. So my silver is balanced. Notice though, you have 1 nitrate here and you have 2 nitrates over here. So in order to balance, I'm going to need to put a 2 out in front of here. That now changes the number of silver atoms that I have, so I need to balance my silver and put a 2 out in front of here. So my equation is now balanced. And that is how you do a metal displacing a metal type of single displacement reaction. So here let's look at a non-metal example. So remember that your non-metals are going to displace the non-metals. Again, you want to re-crisscross any charges for elements that we are combining. So in our example here, I have bromine and I have calcium iodide that I'm combining it with. So I need to see that this is a non-metal, and the non-metal is going to want to switch spots with the non-metal now. So these guys are going to flip. So what I should be left with is the calcium and the bromine. So that's calcium bromide. So metals get written first. And then I should have my iodide on its own. So because it's not combining with anything, we don't use iodide. It should be iodine here. And now I'm going to change this word equation into a chemical equation. Remember that bromine is a Hofbrinkel, so it should be Br2. And I should have now my calcium iodide. So calcium is a +2 charge, iodine is a -1, and I'm going to crisscross my charges. So you come down there and down there. That's going to produce now my calcium bromide. So I should be having C8 +2, and my bromine is -1. So when I crisscross my charges, I'm going to be left with calcium bromide. And finally, iodine, which is also a Hofbrinkel, I'm going to have a 2 at the bottom. Now I'm going to check to see that my equation is balanced. So starting with my metals, my calcium, I have 1 here and I have 1 here. My bromine, I have 2 here and I have 2 here. And lastly, my iodine, I have 2 here and I have 2 here. So my equation is balanced. And that's how you do a non-metal displacing a non-metal. The next type of reaction that we have is a double displacement reaction. So in this reaction, it is going to involve 2 compounds and it's going to produce 2 different compounds. So basically what you're going to do is the metals are always going to switch places with each other. So that's one way to just remember it. So your A is going to combine with the Y as a nonmetal. And then now your X is the other metal and it's going to combine with B. So metals come first, your nonmetals come second. So basically one way to remember it is just recombine your metals. So let's look at a specific example. So here we have lead 2 nitrate with potassium iodide. So notice here that what I'm going to do is I'm going to switch my metals. So my 2 compounds are going to produce 2 new compounds. So my iodide and my lead 2 are going to combine. So metals are first. So I have lead 2 combining with the iodide. And I'm going to have the potassium and the nitrate combining. So remember that your metals are written first. So that is our word equation, and now you want to convert this word equation into a chemical equation. So you're going to crisscross your charges, so lead 2 and nitrate. So remember it's Pb plus 2 now, and nitrate you're going to look on your periodic table. -1. So you're going to crisscross your charges, use brackets where needed. So I'd be Pb, my lead 2 nitrate, my potassium and my iodine. So potassium is +1 and your iodine is -1. So when you crisscross them, the ones are not going to be there. Now I'm going to have my lead 2 and my iodine combining. So it's a Pb +2 and my iodine, which is a -1. So crisscross my charges here and rewrite my formula. And lastly, I'm going to have my potassium and my nitrate combining. So my potassium is +1 and my nitrate is -1. So I'm going to crisscross those there and get my new formula. So once you have your chemical equation, the next thing that you're going to do is you're going to check to see that it's balanced. So I'm going to start off with my metals first. So I notice that my lead and my lead are balanced. I have 1 and I have 1. I have 1 potassium, 1 potassium. And now we can move on to our nonmetals. So I notice here that I have 1 iodine and 2 iodines over here. So in order to balance it, I'm going to put the 2 out in front of here. But that means now that I've also changed the number of potassiums that I have. I have 2 here, but I have 1 here, so I'm going to put out a 2 here. So the last thing that I need to do now is check to see that my nitrates are balanced. Well, I have 2 nitrates over here, and I have 2 nitrates over here. So my equation now is balanced. And that's basically how you're always going to do a double displacement reaction. You're going to switch the metals, recombine them, and write out your chemical equation and balance it.